Hello, how are you all doing? In this video, I'm going to teach you in detail how to solve a quadratic inequality so that everything will be very clear. I'm going to show you how it's done step by step, by hand. But later, I'll also show you another way, how you can do it directly with a calculator like this one. In this case, I'm using the Casio calculator, model FX991CW. So please, pay close attention. We're going to start. Look. The first thing I'm going to do to solve my quadratic inequality is to solve the related quadratic equation, which, as you can see, would be exactly this same thing and also this same thing, except that instead of having a greater than or equal to, I'm going to have an equal sign. So let's see. Let's copy our quadratic equation. So we write 3x squared plus 4x minus 7. And look, here I'm going to set it equal to 0. Pay attention, this is the one I'm going to solve. That would be my first step. Okay, well, and to solve it, we can use different methods. For example, we could use the quadratic formula directly, or we could solve it, for example, by factoring. In this case, I'm going to solve it by factoring. Specifically, I'm going to use the criss-cross method, or the scissors method. So come on, let's do it. Remember that this method consists of looking for two numbers that, when multiplied, or two algebraic expressions. In this case, when multiplied, give me 3x squared. Well, it could be 3x times x, right? Or x times 3x, so I'm going to use 3x times x. I want you to see that I'm placing them vertically, okay? So 3x times x gives me 3x squared, it's written vertically. Now the same thing. But with this last term, we're looking for two numbers that multiply to -7. Well, we don't have many options in this case, right? I mean options for integers. That's what I'm referring to. In this case, it could be, for example, -7 times 1, right? -7 times 1 still gives me -7. Or it could be, for example, 7 times -1 I'm going to try. -7 times 1. Let's see how it goes. Let's see. -7 times 1. Let's see how it turns out. Once we have this like this, we're going to cross multiply. Look. You multiply like this, and you multiply like this. That's why it's called the criss-cross or scissors method. To me, it really looks like scissors, right? So, let's go ahead and cross-multiply x by -7, which gives me -7x. Then we cross-multiply 3x by 1, which gives me 3x. Next, we do this algebraic operation. -7x plus 3x, which gives me -4x. If the number we've arrived at, or in this case, the algebraic expression we've arrived at, is exactly the same as the one we have here in the middle, does that mean then that we originally broke down the numbers correctly? I mean, this part I have here in green, but as you can see, I didn't break them down correctly. Why is that? No, because I'm getting -4x and it should have been 4x, so I'm not correct. So how can I fix this then? Well, I think it's pretty simple, right? Let's see. I'm going to do a little Control-Z to go back, and now I'm just going to correct it a little bit. Look here. How would I fix it in this case so that it works for me now? Well, instead of this being a -7 and the other a +1, what do you think? If now this is a +7 and this one is a -1. Notice that when I do that, it will work for me, right? Let's do it so you can see. 3x times -1 gives me -3x. Then x times 7 gives me 7x. We do this algebraic operation. 7x minus 3x. And yes, I get 4x. So, what I got here is the same as the term in the middle? Well, yes. Does that mean then that in this case we did break it down correctly? And that's it. It's that simple. Now what is this I just did useful for? Well, it's so I can express my trinomial as a product of factors. That is, to be able to factor it. So, how do I go about factoring it? Very simple. Look, we're going to put these numbers, or these expressions, but like this, horizontally. Sorry, completely like this, horizontally. So in this case, I'm going to write 3x plus 7, and I'm going to write x minus 1. Like this, horizontally, remember. So, here we go. I open parentheses. I put 3x plus 7, which is this. And now, I open another parenthesis. And now, we put x minus 1, x minus 1. Done with what I just did. Again, any questions, okay? I just factored this trinomial, and why do I want to factor it? Well, because now it's going to be pretty simple. Let's solve this quadratic equation. Pay attention, the quadratic equation, not the inequality. For now, don't forget that we're focusing on solving the quadratic equation. That's going to help us, because I need to find exactly those roots. Those roots of the quadratic equation. They're roots that we're going to need, or well, they're numbers that we're going to need for our solution to the quadratic inequality. So let's continue, so you don't get lost. Well, this right here, I mean, the 3x plus 7 times x minus 1 is already the factorization of the trinomial I have over here. So I can set this equal to 0, right? Because again, what I have here is exactly what we have over here, but already factored, so I can still set it equal to 0. Once we have it like this, let's do the following. You're going to set each of these factors equal to 0. So, go ahead. Set this factor equal to 0, and also set this factor equal to 0. And then you solve for x. So, let's do it. That gives me 3x plus 7 equals 0. And from here, we're going to solve for x. So what would x be equal to? Well, we can move this 7 to the other side by subtracting, and this 3 by dividing. All right. So now we have that one of the two values of x that satisfy this equation is x equals negative 7 over 3. There's the first one. So how do we find the second? Well, now with this other factor, we have x minus 1 equals 0. And well, it's very easy to solve here, right? X equals 1. Got it? Up to this point, what I've just done is solve the quadratic equation we have here. Okay, this quadratic equation, remember, is exactly the same as what we have over here. But instead of having a greater than or equal to, we have an equals sign, right? So it's the quadratic equation related to my inequality? All right. Once we have this, the rest is pretty simple, because we've actually already done the hardest part. The next step is as follows. Sorry for the redundancy there, okay? I'm going to draw a line here. Well, it's a little crooked, but you get the idea, right? Now we draw a line over here. I'm going to add arrowheads. Over here I'll put infinity, and on this side, negative infinity. Now, let's place the two roots that we found, which in this case are negative 7 over 3 and 1. So for example, they could be somewhere around here, right? I mean, around here. I could put negative 7 over 3 here. Let me put it like this, negative 7 over 3. And over here, I'm going to put, for example, 1. It really doesn't matter where I'm placing them. Okay, because I don't really have any other point of reference. Just this. It's important that we place negative 7 over 3 to the left of 1, right? Since negative 7 over 3 is less than 1. We're all set now. I need you to forget about the quadratic equation for a moment, because now we're going to focus on our inequality, that is, on the main problem. Look, it's important that you recognize 3 intervals here. The first interval will be all the values of x that go from negative infinity up to negative 7 over 3. That is, all of this over here. That's my first interval. Then there's another interval that includes all the values, or rather, that covers all the values from negative 7 over 3 up to 1. That would be the next one. But then there's another interval that includes all the values that go from 1 to infinity. So as you can see, there are 3 intervals. Well, what we have to do next is see for which of those intervals my inequality holds true. And how are we going to do that? Well, simply by evaluating. And notice that I've been watching because I started checking what were my colleagues doing to see if the way they explained it was much simpler than the way I like to explain it. But I saw that most of them are really getting into explaining, actually, considering some theoretical aspects. And I think that while that's correct, it can confuse you. So what I'm going to do might take a little longer, but I think it's much simpler. What are we going to do? Simply substitute some values, and that's it. What do I mean by substituting some values? Well, look, I'm going to take a value that's within this interval, whichever I want, but it has to be within this interval. What's in this interval? Well, there's minus 500, minus 600, minus 8, minus 56.46. I mean, all those values that are less than negative 7 over 3. Negative 7 over 3, how much is that as a decimal? It's about negative 2.3, I think. Let me check quickly. 7 over 3 is negative 2.3. So, all the values that are less than negative 2.3 will work for me to do the first test. So, let's see. Start thinking of a value that's less than negative 2.3. Well, a very simple one could be negative 3, right? Or negative 5. I think it's easier with negative 5. So, let's see. I'm going to work with negative 5. Let's suppose it's around here. So I'll put it like this, negative 5. And I'm going to work with this value. I repeat. Why? Because that value is in this first interval that goes from negative infinity up to negative 7 over 3. So let's try it. Where? Well, directly here, in the inequality. All right. Let's substitute little by little again. So you don't get lost. Let's go. So we write 3, open parenthesis x squared, but in this case x. I'm giving it a value of negative 5, so I get 3 times negative 5 squared. Then comes plus 4 times x, which means 4 times minus 5, and finally, minus 7. This should be greater than or equal to 0. But we don't know if that's going to be true, so let's test it. If it holds for negative 5, it means it will hold for the entire interval. That's why it was important for us to know the roots of the equation, not the inequality, the equation. Let's see what this operation gives us. We can do it by hand or with a calculator, whichever you prefer. It doesn't matter to me. The point is that you know what you're doing. I think that's the most important thing. All right, let's continue. I'll do the calculations. Negative 5 squared is positive 25, and 25 times 3 is 75. So here I get 75 odd. Here we have positive 4 times negative 5, which gives me negative 20, and over here we have negative 7. Now, even without doing this operation, you'll agree with me that this operation is greater than or equal to 0, right? Why? Because 75 minus 20 minus 7 does give me a positive value. So this is greater than or equal to 0. So, does that mean that for negative 5 it is satisfied? In other words, that this inequality is true? For the interval from negative infinity to negative 7/3, for that value, or for that interval, it is satisfied. Let's see what happens now. For example, for this interval we have here, let's check it. Here we have from negative 7/3, which we said was about negative 2.3, up to 1. A very simple value, I think, would be 0, right? So let's try with 0. So what do we do? Well, the same thing. Let's plug 0 into the inequality. So I would have 3 times 0 squared plus 4 times x, or rather, times 0 minus 7 has to be greater than or equal to 0. Without doing the calculations, we realize that it's not, right? Why is that? No, because this cancels out. This cancels out, and I'm only left with negative 7, and negative 7 is not greater than or equal to 0. So let's see. This one was true. This one is not true. So what does that mean? That for the entire interval between negative 7 over 3 and 1, the inequality is not satisfied. So here we're going to say that it's not satisfied? Are you following me with that? Because what comes next is pretty simple, right? It would just be pretty repetitive. So let me just move this a little bit so it still looks good. Because now we're going to try with another value. In this case, for example, I'm going to try with 2, which is also pretty simple, right? Obviously, I could try, for example, with 100, 500, 10,000, 152 million ACs. But obviously, that's not convenient for me. It's better to do it with small numbers because it's much easier to work with. But it's important to point out that whatever result I get when I evaluate at 2, if it works for 2, then it means it has to work. For any number that is within the interval between 1 and infinity, we agree on that. Perfect. So let's go ahead and substitute now. So I have 3 times x squared. In this case, I put 3 times 2 squared. Then comes plus 4x, which means plus 4 times 2, and then minus 7. This should be greater than or equal to 0. Well, yes, it is going to be greater than or equal to 0. Look, we have a big positive, another big positive, and over here we have a negative 7. But anyway, I'll do the calculations. 2 squared is 4 times 3 is 12 plus. Here we have 4 times 2, which is 8, and well, here we have negative 7. This has to be greater than or equal to 0. And obviously, this is greater than or equal to 0. So yes, it is also true when x is equal to 2. And that's it, at this point. So now we have the intervals for which that inequality will hold. In other words, we already have the answer to the inequality. How can we represent it? Very simple. Let me erase this part that we already have here, which is actually the easiest part, since it was just about substituting, right? Let's see. And now let's write down our answer. How are we going to present it? Look, let's first put a parenthesis to express that we are coming from negative infinity. Remember that when we use either negative infinity or positive infinity, we must use parentheses. Why is that? Since that value isn't included, we start from negative infinity with a parenthesis. Then we put a comma, and now we're going to write this root, right? Which would be negative 7/3. Why am I writing this negative 7/3? Because we agreed that for this interval, it does work, right? In this case, start thinking. Are we going to use parentheses or brackets? Very good. We're going to use brackets. Why is that? Because here it says it has to be greater than or equal to 0. When we put in a negative 7/3, this right here will give us 0, right? Because that's exactly what we found when we solved the quadratic equation. Isn't that true? Do we all agree on that? Perfect, all right. So now we have this first interval. Now we had said that the interval here wasn't good. I mean, that one doesn't work, right? Why? Because if we substituted a 0, we already saw that the inequality wasn't satisfied. So we're not going to consider that as part of the solution. But which other one? Yes, this one, right? From 1 to infinity. And what do I do now? So how do I include that other one? It's very simple. We're going to use this symbol, which means union, and we're going to open the bracket again. Why? Because it can include the 1. We're going to write 1, put a comma, and then infinity. And here, next to infinity, we agreed that we have to put a parenthesis. That's it for now. So we already have the solution to our inequality. Let's read it. We have that the values for which the inequality holds are from minus infinity to minus 7/3, including minus 7/3. Union from 1 to infinity, including 1. That's it. We have it now. So we could solve it by hand like this. As you can see, if you already know how to solve quadratic equations, then the rest is basically just substituting and finally interpreting a little bit. But it's actually pretty simple, right? But many times we need to do the process a little faster. So I'm going to show you right away how to do it directly with the scientific calculator. Look, let me share the emulator with you. I'll put the emulator on because it's much simpler. Otherwise, I'd have to show you the calculator screen here, and you wouldn't see which button I'm pressing. So, let's do it directly here. Look, we're going to press here where it says, here where the arrows are. And we're going to move. See? I'm going forward. We're going to move until it says inequality here. So, OK. Then we press OK. Once we're here, we're going to select the degree of the inequality. In this case, we have a quadratic inequality, so we're going to select this first one. Now let's see what the quadratic inequality looks like. In this case, we had 3x squared plus 4x minus 7 greater than or equal to 0. So we're going to look for the one that has the same structure. We scroll down and it's this third one, right? Look, x squared plus bx plus c greater than or equal to 0. So we click OK, and now we're just going to enter the values, or, well, the coefficients. In this case, it says it's 3x squared. So I put a 3, I click execute, then comes plus 4x. So I put a 4, I click execute, and then it's minus 7 minus 7. I click execute, done. When you click execute, it will give me the intervals, which are the solution. So, all right, we click execute, and that's it. I want you to notice that in this case, it's giving me the solution in a different representation. But basically, it's the same thing, right? Look, it's telling me that x is less than or equal to negative 7/3. That's true, right? We had agreed that x goes from negative infinity up to negative 7/3, also including negative 7/3. So this first part is correct. Then it has a comma and says 1 less than, or equal to x. Careful. 1 less than, or equal to x. What does that mean? Well, that x is greater than, or equal to 1, right? So that's also being satisfied. We had agreed that the other interval was the one that goes from 1 to infinity, including 1. We agree on that. And so, as you can see, In just a few seconds, we solved exactly the same exercise. With the help of this Casio scientific calculator, well, that's all for today. If you liked the video, please subscribe to Matematicas con Grajeda, and also let me know down below in the comments if you would like me to make more tutorials on how to use your Casio scientific calculator. See you next time. Take care and behave yourselves. Bye-bye.